This is our dynamics lesson 2, and we will be talking a lot in this question and these questions that we're going to be solving about the free body diagram. And I mentioned it in a previous video, so I'm going to repeat it one more time, that the free body diagram is a diagram that represents the object and the forces that act on it. Like in this case, you see that two men pushing the car with 275 newtons force and 395 newton force, and the car is opposing this motion or the change of the motion by them pushing the car with 560 newton. So I can show in my diagram. So right here you can see the free body diagram, and you can see that two forces, and I'm going to choose the positive direction to the right. So 275 newton force and 395 newton force are positive forces, and 560 newton force is the negative force, the force of friction. So let's look at some questions and see how we can write the free body diagram depending on what case we're looking at. Here's our first question. So the question states that two blocks of identical material are connected. Identical material, that means coefficient of friction is the same for both of them. Identical material are connected by a light rope on the level surface and applied force of 55 newtons. So applied force in this direction, 55 newtons. So this is applied force and it is 55 newtons. Causes the blocks to accelerate. While in motion, the magnitude of the force of friction on the block system, so on both blocks together, is 44.1 newtons. So there is the friction force, which is 44.1 newtons, and it's combined together. Calculate the acceleration of the blocks. So as always, I'm going to combine these two blocks together because they're the same material, same friction, everything is the same. And I'm going to say the force that is acting on them is 55 newtons, so that is going to be called F, force F. The force of friction is 44.1 newton, and there are also two more forces. One is the force of gravity. I have to always write that one, so equal to mg, and there is the normal force. But the purple forces, the ones that is normal and force of gravity, cancel each other because there is no acceleration that way. With their balance, I can call those purple forces, the vertical forces are balanced. But the horizontal forces are not balanced, and because they are not balanced, there is going to be acceleration. So I'm going to start with the second Newton's law and say the net force. Sometimes you will see me writing the sum of all the forces, that's the same as the net force, horizontally is equal to ma, and it's acceleration horizontal. So the net force, I'm going to choose the positive direction to the right, as I said. I have 55 newtons to the right and 44.1 newton to the left, and equals to the masses of both blocks together give me 30 newtons, or 30 kilogram, and that is times acceleration. So the acceleration in this case is equal to 0.36 meters per second squared. So I found acceleration. I also can tell you how much force exactly is acting on each block. So if I say, let me choose different color, this is going to be how much force is acting on 20 kilogram block, and maybe the gray one is going to be how much force is acting on let's do the blue one so it's easier for you to see it, and the blue one is how much force is acting on the 10 kilogram block. So the net force acting on the 20 kilogram block, so this is the net force on 20, is its mass times acceleration. So that gives me 736, 3.6 times 2, right? So that is 7.2 newtons. And the net force acting on the 10 kilogram block, is 10 times 0.36, the acceleration. So that gives me 3.6 newtons, the net force. And of course there is a friction acting on them, but I just wanted to show you that you can calculate individual force acting on a certain block this way. Here's another question that I want to look at with you. And this question says that two objects are connected by a light rope over a light frictionless pulley. One has a mass of 22 kilograms and the other one is 35 kilograms. Determine the motion of each object once the objects are released and their acceleration, and what is the magnitude of the force of tension. So I'm gonna draw the forces acting on each object. So let's say the blue one is gonna be 35. So let me call this one M1, and this is M2. I'm gonna redraw them. So I have M1. So the force of gravity is acting on it, M1G, and the tension force. Let me call it tension 1 for now. And then you have the rope. And you have another block, and I'm gonna call this the force of gravity on this one is M2G, and the tension I'm gonna call it T2, and here is the pulley. So what's given here is M1, we're gonna choose 25 kilograms, and M2 we're gonna choose 35 kilograms. And even though acceleration due to gravity is also 10, so M1G and M2G to calculate those. Then to talk about the T1 and T2, if you look inside of the rope does not know what is happening to it. No matter which part of the rope you look at, so maybe you look at this part, let me do it in a different color, at this part or at this part or at this part of the rope, it doesn't know what's happening, it just feels tension. So I can say that T1 and T2 is the same tension because they feel the same tension. So this is T1, which is T, so I'm just gonna call it T, and T, it's the same force of tension, so I'm just gonna call them both T. So far I have two forces acting on my masses, the tension and force of gravity, and also there's going to be acceleration. So when they say draw the free body diagram, your free body diagram, this is why I redrew it so it's going to be cleaner. The free body diagram includes only the forces, so the red ones are the forces. It doesn't include the acceleration. And because mass 2 is heavier, then acceleration is going to happen in this direction for 25 kilogram mass, and in that direction for the 35 kilogram mass. So because I have all this information that is given, I can do my net force for each, or second Newton's law for each of these masses. So at first I'm going to do mass 1. So for mass 1 I have, and I'm not going to plug in the numbers until the end as always. So I want to know how to derive the formulas, not how to plug in the numbers. The answer at the end is not as important. The deriving the right formula is way more important. So what I'm gonna write right here, the tension is positive force. So what I'm doing is F net is equal to MA. I am deriving these formulas for each mass. So for mass M1, T is positive and mg is negative, so minus M1G, and equals to acceleration in the positive direction, it's up. So that's M1A. And then for M2, I have tension is positive minus M2G, and equals to, here I have M2, M2A, right? M2A, but in this case my acceleration is negative, it's pointing downward. So I have the system of these two equations, and here I have to be careful. So both of my mg's are negative, tensions are all both pointed up, and one acceleration is pointed down. This is on the second mass, and then I have to write the negative right there. Then again, I have to solve system of equations as before. So I'm going to solve both for t. T of the first one is equal to M1G plus M1A. And if I solve the other one for t, t is going to be equal to, for in the other equation, M2G minus M2A. So I solve for t the first and the second equation, and then I just set them equal to each other. So I don't even have to keep this t right here in my equation because both of the sides is equal to t. And then I'm solving for acceleration. So I'm going to move my a's to one side. I think I accidentally wrote g right here. This is a. Okay, I'm going to move my a's to one side, and I have m1a plus m2a is equal to m2g minus m1g. I'm going to factor out a, so I have m1 plus m2, and then I have g out, m2 minus m1. Then my acceleration formula is equal to, I can keep g in front, and I have m2 minus m1 over m1 plus m2. And now I can plug in the numbers and figure out what my acceleration is equal to. And I get 1.67 meters per second squared. That is acceleration. And then I can take my acceleration and plug into any of the equations right there to find the tension. So now I'm going to plug into tension. I'm going to choose the first one. So then my tension, I'm choosing the first equation, my tension is equal to, that is the tension, correct? And this was the tension for the second equation. So the tension is equal to m1g plus m1a. I can take mass out, m1, and g plus a. Now, if I plug in my numbers, m1 is 25, g is 10, and acceleration I just found 167. I get 292 newtons is the tension force in the rope. Here's one more question that we're going to look at in this video. Two objects with a mass of 3 kg and you see 3 kg and 5 kg are connected by a light string that passes over a frictionless pulley as shown. Determine the tension in the string, acceleration of each object, the distance each object will move in the first second of motion if both started from rest, and the distance each object will move between the 2 and 3 seconds for their motion if they both started from rest. So again, I'm gonna draw my forces. At first, this one I'm gonna call m1ag, force of gravity. Tension is the same for both of them. I already know this one, so tension. Again, I have tension on this object, and I have m2g. And because the right object is heavier, that one is the 5 kg. This is the free body diagram, and you stop here, you don't do anything after this. Also on the AP exam, they will not give you like the object itself. They just put the dot and say this is mass 1, place the forces acting on it. So make sure that you have like m1g, and the tension force is stronger, so you want to make tension force is stronger because there's going to be acceleration upward. So in this case, tension is stronger. For the second body, you have m2g is stronger, m2g, because an object is going to be accelerating downward, and you have the tension, and make sure the tension in both cases are the same. The length of the tension is the same because the tension is the same. And then also, I heard that they don't give you points if your forces do not touch the dot that they provide for you. So make sure that the forces are touching the dot on the AP exam and you don't show any acceleration. So that would be the free body diagram for each object. But in our case, we need to see acceleration because we have to choose positive and negative direction. So we're going to choose here acceleration is up again, and for the second body acceleration is down. That is not the part of the free body diagram. Now I'm going to write the equations for both m1 and m2. So I'm going to call this is m1, this is m1, and this is m2. So your 3 kg is m1 and your 5 kg is m2. So I have the tension for the first one minus m1g is equal to positive m1a because acceleration is up. For the second one, I have the tension minus m2g and equals to negative m1g m2a acceleration is downward. If I solve both of them for the tension and set them equal to each other, I'm gonna have m1g plus m1a is equal to m2g minus m2a. Solving both of them for a, moving all of them a's on the other side, one side, and g's on the other side, I'm gonna get a is equal to g, and then I have m2 minus m1 and m1 plus m2. And if I plug in my numbers, so my m1 I said would be 3 kilogram, and m2 I decided to be 5 kilogram. Now if I plug in all my numbers, I get acceleration of 2.5 meters per second squared. Now if I know acceleration, I can find the force, the tension force, by plugging in my acceleration that I just found. So the tension force is equal to, if I plug in m1 as 3 kilogram, g is 10, m1 is 3 kilogram, and acceleration is 2.5 meters per second squared, I will get my tension is 37.5 newtons. Next question, they ask you the distance object travel over the first second after it started moving. So for that part, I have initial velocity was 0 meters per second, and the final velocity is equal to initial velocity, which is 0 plus acceleration times the time, 1 second, they said. So the final velocity is 2.5 meters per second, because they say after the first second, moved after the first second. So the distance it moved is average velocity times the time. So I have to find the average velocity between these two times 1, which is 1 second. So I get 1.25 meters. So they move both 1.25 meters in 1 second. And the distance the two objects traveled between the 2 and 3 seconds. So for the next part, let me do it in blue. For the next part, I need the velocity at 2 seconds. So my, let me maybe write the formula here. So the velocity final is equal to initial velocity plus acceleration times the time. So the velocity at 2 seconds is equal to initial velocity is 0, and 2 seconds later with this acceleration is 5 meters per second. And velocity at 3 seconds, again, initial velocity is 0, acceleration is 2.5, and in 3 seconds, I will get 7.5 meters per second. So the distance traveled between 2 and 3 seconds is average velocity, which is 5 plus 7.5, which is 12.5 average velocity, times the time, and it's between 2 and 3 seconds, so it's just 1 second time. So I get 6.25 meters. So they will both travel 6.25 meters over between the second and the third second. Let's look at this example. What you have here is three objects with the masses of 10 kilogram, which is m1, and mass of 27.5 kilogram, mass 2. They are connected by a string that passes over the massless and frictionless pulleys. The objects move, and the coefficient of friction between the middle object, that is 80 kilograms, and the surface is 0.1. The coefficient of friction is just 0.1. It doesn't have the measurements. Because m2 is heavier than m1, we know that the objects will move to the right. So let's write the forces here. I'm gonna call this force T1 and this force T2. And this is also T2, and this is also T1 and T2. And I can call these two forces T1 and T2 because they're not the same. T2 is different rope than T1, and T2 is stronger than T1. That's why the objects will be moving to the right, because M2 is heavier than M1. Then I also have I'm gonna call this one mg, and the normal force, and I have m1g, and I have m2g. Then I have acceleration up on this object, I have acceleration to the right on the middle object, and I have acceleration down on the right object. And the friction, because the middle one is moving to the right, the friction is going to be to the left. So the friction is opposing the motion. And it is kinetic friction because the block 80 kilogram is moving to the right and it's sliding. So I have to write my net forces for every single mass. So I'm going to do M1, let's do M1, M2, and M, the middle one. Try to write M1 and M2 on your own and then compare them with mine. Pause the video right now, because if you don't pause it, you're going to see the answer right away. So pause the video and try the equations for M1 and M2. And I hope you got something like this. So T1 minus M1G equals to M1A, A is the positive direction. And for the second mass, T2 minus M2G equals to negative M2A, and acceleration is negative, so I place the negative there. Let's write the middle one on together. So what I have in the middle, two forces, the normal force is mg, they cancel each other. So vertically, on the 80 kilogram mass, I have the vertical, the y forces. I have net force n minus mg, but there is no acceleration, so the net force is equal to 0, and then the normal force is equal to mg. Also, I know that the friction force is equal to mu times n. So in this case, I can say the friction force is equal to mu times mg, because n is equal to mg. So for the middle force, I have this. T2 is positive, T1 is negative, and the friction force is negative. And then I have m times a. And instead of the friction force, I can write what that friction force is equal to. So I can erase, because I have limited space here, I can erase my friction force the way I wrote it, and I can write it as mu times mg. Then I'm going to solve for T1, and then I'm going to solve it for T2, and I'm going to plug in, instead of T, the first one was T2 minus T1, right? I had T2 minus T1, and then I'm going to plug in T1 and write and see the equation. So try to plug in your T2, solve for T2, and solve for T1, and plug them in. And be very careful with this negative sign right here and the negative sign here, and then you have equals to. But this negative sign, the first one, is really important not to mess up. So try to write the equation, and then after you pause, look at the equation I wrote it. So what I did here is I solved for T2, and that is M2G minus M1 M2A. And then I solve for T1, which is T1 is equal to M1G plus M1A. But when I subtract and drop the parentheses, then that sign is going to change. And then I have the rest of it. Now I'm going to solve for A. So again, pause it and see if you can solve for A, this equation. You have to move all A's on one side and everything else is on the other side. So I hope you got the first equation when you solve it for all the M and A's moved on one side, all the variables with A's. So you have this on one side, and so this part on one side, and everything else without A on the other side. Then I factor out A from my left side, I factored out G from my right side, and I will get acceleration equals to. So I solve for A, and then I plug it in my numbers, and I have acceleration is equal to 0.8 meters per second squared. Now, since I know acceleration, I can go back and I can plug in into my tension formulas. So I'm gonna plug it in into both tension formulas and find what tension 1 and tension 2 is equal to. And I get tension on the left side, tension 1 is 108 newtons. If I plug it in, and tension 2 on the right side is 253 newtons. So I solve for the second tension as well. So I want to fit this question within our 30-minute lesson today. So the problem states that 3 blocks are in contact with one another on a frictionless horizontal surface as shown. A horizontal force is applied to M1, and they give you what the masses are. Find the acceleration of the blocks, find the resultant force on each block, and find the magnitude of the contact forces between the blocks. So the first part, they ask you to find the acceleration of the blocks. Again, I'm gonna start with F net is equal to mass times acceleration. The only force is acting on them, the net force is 25, and there's no friction, I don't have to worry about that part. And the mass of all the objects together is 10 kilogram. So the acceleration of all of them equals to 2.5 meters per second squared. Then find the resultant force on each block. I'm gonna do it in purple. So the net force, the force acting on 1 is M1A. The force acting on 2 is M2A, and the force acting on 3 is M3A, and they are equal to, the masses are given 2 kilogram, 3 kilogram, 5 kilogram. So 2 times 2.5 gives me 5 newtons, and 3 times 2.5 gives me 7.5 newtons, and 5 times 2.5 is going to give me 12.5 newtons. And the sum of all the forces should give you the 25 newtons as you had before. And for C part, the magnitude of the contact force between all the blocks, I'm going to redraw the blocks so it's going to be easier for us to see this. So I have 1, 2, and 3. So I have the force here acting on this one is 25 newtons, and this force accelerates all 3 blocks, and the force is between 2 and 3 kilogram block. So the force right here between these two will accelerate these 2 blocks. So the force that is 1 acting on the other 2, let me call it 1, 2. So the force 1, 2 is equal to acceleration that we found, 2.5, times the mass of the other 2 blocks, 8. So the force between first one and the second block, which is 1, 2, is equal to 20 newtons. Now to calculate the force between, let's do it in orange, between the second and the third block, to calculate the force between the second and the third block is going to be the acceleration, because I need to know what force is applied to cause this block to move with that acceleration. So I'm going to call it 2, 3, and that's acceleration 2.5 times the mass of that block, which is 5 kilogram, and that gives me the force between second and the third block is equal to 12.5 newtons. That will conclude our second lesson on dynamics, and the third one is coming, so push the link on watch next and you will see the third dynamics video. And if you need to review the first video on dynamics, you would push on the link in the description that says watch before this video. And I also have in the first video description the links related to regular physics classroom, which are a little bit easier. So if you want to start with easy examples before you jump to more difficult examples, you want to watch regular physics classroom explanation and problem solving.